Here we go. Back for part 2. And I have fixed the coordinate plane so that we are counting by 2's on the y-axis so that we can plot all of our points. So first I'm going to plot my vertex. We have a vertex at 3, -4. 3, -4. There we go. And our y-intercept is 0, 14. And our other point is at the same value on the y-intercept, but 3 points on the other side of the vertex. So we are at 6, 14. And there is your beautiful parabola. Now, of course, I'm not going to let you watch me draw the parabola, so just hold on one second. There we go. Movie magic strikes again, and there is our parabola. You try. When you're ready, pause this video, and then when you come back, everything will be done, and you can check your work. Good luck! Alright, here we go. This one was kind of tricky because, again, the graph was a little bit off. So if you chose not to make your own, like I didn't, this is what you could have done. So you were able to identify A as -1, so we knew the parabola was going to open down. The parabola is also going to have a maximum because the vertex is going to be above the roots. The axis of symmetry is going to be x equals -5, which would make the vertex -5, 2, based on the quadratic function in vertex form. So when you plug in 0 for x, you are going to get 0, -23. So since I didn't want to redo the graph, I just redid the y-axis and I counted by 5. So I was able to plot my vertex at -5, 2, and I was able to plot my y-intercept at 0, -23. That worked. Then I realized I wouldn't be able to do my symmetrical point on the other side where the y value would equal -23 as well. So I looked at the very last value on the x-axis that I had here and saw that it was -7. So I took that -7 and I plugged it in for x. I plugged -7 into the function in vertex form and I solved for y. And when I plugged -7 in for x and solved for y, I got a y value of -2. So that's where I got the point -7, -2. And that would have made my parabola end right here. So if we were to get rid of all of this, my parabola could end just like that, right there. And that's fine. But I wanted to show you that it could still be symmetrical. So then, just to prove that this would still work, I found my other symmetrical coordinate with a y value of -2. It would be -3, -2. That would make this point symmetrical. And then somewhere over here, if there was any more coordinate plane over there, that would be -10, -23 to make it symmetrical. This is definitely not the most beautiful drawing, but it is another way to find a parabola if you don't have a big enough coordinate plane. It's another way to find another point. Plug in the value for x, solve for y, just like a table of values. Scroll down, graphing in factored form. Alright, when we're graphing in factored form, P and Q, we know, are the x-intercepts. Also called the roots. They're also called the roots. And another way to find the axis of symmetry would be to take the average of the roots, P plus Q divided by 2. So let's find our roots in example 1. So our first x-intercept is 0, no. First x-intercept is 1, 0. The second one is -2, 0. And then the axis of symmetry would be 1 plus negative 2 divided by 2, which would give us negative 1 divided by 2, which is negative 1/2. So the axis of symmetry would be negative 1/2. The second one, our x-intercepts are negative 3 and negative 3, 0. So we don't need to do this twice because there aren't two x-intercepts. So really, this should only be written one time. And this function should and could actually be written as x plus 3 squared rather than x plus 3 times x plus 3. So since the only root is negative 3, 0, that is also the vertex. So we already know that our axis of symmetry is negative 3. And the last one, try this one on your own, pause, and come back to check your answer. Here we go. Your roots are 7 and negative 1, which gives you an axis of symmetry of 3. Now let's graph this. So here we have our A. A is always out front. So A is negative 2. A is negative, so we know that this parabola is going to open down. The axis of symmetry is at x equals 2.5. X equals 2.5 for the axis of symmetry. To find the vertex, we are going to take our x value of 2.5 and plug it back in to the original equation that we are given. So the x value of our vertex is half, 0.5. Now by looking at our function, negative 2 times the quantity x minus 3 times the quantity x minus 2, we can pull out our x-intercepts. We have 3, 0, and 2, 0. We can find the y-intercept by plugging 0 in to the equation because the y-intercept is when x equals 0. So the y-intercept, when the value of x is 0, y is negative 12. So then we need to find another point on this graph. Now our other point could be 5, negative 12, and I did extend my graph a bit. You could also plug in any value of x to find a second point on the graph. But I felt like being symmetrical for this one, so I just extended my graph a bit. You could easily draw another graph over a little bit on this page. Alright, so let's plot some points. Starting with the vertex, we are going to do 2 and a half and half. So that'll be about right there. Then we have our x-intercepts, 3 and 2. So there's x is 2 and x is 3. This is a teeny tiny parabola. Then we have our y-intercept of negative 12. 0, negative 12, which would make our other point at 5, negative 12. Oof, this is going to be a tough one to draw. Hold on one second so I can draw it without you watching. That actually was the easiest parabola all day. I drew it in the first try, and it doesn't look that awful. But there you go. There is our example for graphing a function in factored form. So now, coming down here, you are going to try. Pause and come back when you are finished. I wanted you to be able to see the points before I draw the parabola. A is positive 1, so the parabola will open up. When we calculate the axis of symmetry, we get x equals 1.5, which makes our vertex 1.5, negative 6.25. The x-intercepts are negative 1 and 4. When we plug in 0 for x, we get negative 4, so our our y-intercept is negative 4. And then to be symmetrical, we put in another point at 3, negative 4. Now I can draw the lines for my parabola. Look at that. No movie magic there. I drew it on the first try. It's not that pretty, but that's okay. Alright, and those are your notes for graphing in standard form, vertex form, and factored form. Now, I do have some more notes on the next page down that we are also going to do a bit of. This notes page is called More Notes for Vertex Form, and we are going to do some transformations in vertex form. So the first thing we're going to look at is the parent function, aka the OG function, which is f of x, or y, equals x squared, and that's it. So here's a table of values. I'm just going to plug in the values negative 1, 0, 1, and 2, and we are going to plug it into the OG function, and then we can graph this parabola. The table of values was bothering me because it did not make a symmetrical parabola, so I just added a fifth box at the bottom so we can have a symmetrical parabola. So there we go. Here is our parent function. Now we are going to transform this parent function using vertex form. So let's look at this function. Okay, so we have the three parts of vertex form, A, H, and K. A does a lot. If A is greater than 1, it's going to have a vertical stretch effect on your parabola. That means it's going to stretch up and down, so we're going to get a more narrow graph. If A is between 0 and 1, so if A is a fraction, we are going to get a vertical compression. So that means how wide the graph is going to change. It's going to be a wider graph. And as always, if A is negative, we are going to have a reflection over the x-axis, which means the parabola is going to open down. In example 1, we're just going to describe the transformation of the parent function. So remember, our parent function is right here at the origin, symmetrical across the y-axis. So the first example, example A, we can see that the A value is a positive 1. So we know that we are going to have a positive parabola. The wideness is not going to change. H equals 3. So that means our parabola, our parent parabola, is moving to the right 3. K equals 2. So our parabola is going to move up 2. So the wideness is going to stay the same. It's moving to the right 3 and up 2. Example B has a negative A. That means it's going to reflect over the x-axis and it's going to be negative. H is 2, so we are moving to the right 2. K is negative 6, so the parent function is going to move down 6. So you are flipping your parabola over, moving to the right 2, and then moving down 6. Now, freeze the video and do C on your own. Are you sure you're finished? Okay, last chance. Alright, here we go. A is negative, so your parabola is going to flip over and be a negative parabola. H equals negative 4, so you are going to be moving to the left 4. And then K is negative 1, you are moving down 1. And all this is in relation to the parent function, so this is a movement from the parent function to a new function. Alright, moving on to video number 3.